So chapter 1 is all about linear equations, inequalities, and applications of those linear equations and inequalities. The first chapter we're going to go over, the first section 1.1 is all about linear equations in one variable. So let's go ahead and take a peek at that. So an equation is a statement that two expressions are equal. So to solve an equation, what we want to do is we want to find all possible numbers that make the equation a true statement. What we're looking for is all possible values of x. So here I have x plus 2. What value of x would make this a true statement? Well, we're going to have to learn some steps. I know now you look at this and you see, oh yeah, 7. 7 plus 2 would be 9. But if you weren't sure or it was more complicated, we'd want to go ahead and have some steps to solve this. So the steps for solving linear equations are these. First, we have to simplify our expression on each side. Next, we need to collect all of our variable terms on one side and the constant terms on the other. It doesn't matter which is on the left and which is on the right as long as they're together. Then we need to isolate our variable. Remember, we like our x's lonely. Okay? Next, we're going to check our answer. It's always a good idea to check your answer, especially on an exam, by plugging our solution back into the original equation. So here I have 5x plus 7 equals negative 3, and I'm going to go ahead and solve for x. So the first thing I'm going to do is subtract 7 from both sides. I get 5x equals negative 10, and the reason I did that was to move my constant to the other side, because there's no way I could have further simplified each side. Next, I have to divide by 5. So I get x equals negative 2. In order to check my solution, I can plug that back in. 5 instead of x, I now have negative 2 plus 7 equals negative 3. 5 times negative 2 is negative 10 plus 7 is negative 3. Negative 3 equals negative 3. This is a true statement. Awesome. Let's go ahead and solve the next problem. I have 4x equals 16. 4x equals 16. I can't simplify either side. I don't need to collect all my variable terms on one side or the other. I can just go ahead and isolate my variable by dividing by the coefficient. I get that x equals 4. I can check my solution. 4 times 4 equals 16. That's a true statement. Remember, the golden rule of algebra, much like the golden rule of life was, treat others the way you want to be treated. The golden rule of algebra is do unto both sides as you would do unto one. If you add to one side, you have to add to the other. If you multiply one side, you have to multiply the other. Treat both sides of your equation equally. There are 3 types of linear equations you're going to encounter. The most common are going to be conditional equations. Conditional equations have one solution, much like the last 2 examples we did. Second, we have identity. Identity equations have infinite solutions. What does that mean? Well, let's take a look at this example. 5x minus 15 equals 5 times x minus 3. So I have 5x minus 15 equals 5x minus 15. Do we kind of see something going on here already? If I add 15 to both sides, I get 5x equals 5x, or I get x equals x. I also could have done this where I subtracted 5x from both sides. Then I would get negative 15 equals negative 15. Both of these are true statements. As long as I get a true statement as my result, it's going to have infinitely many solutions. Why is that? Well, what could I plug in for x here and have this be a true statement? I could plug in 1. I could plug in the square root of 2. I could plug in a fraction or a decimal, right? It's going to be true for every single value of x. So this is an identity, and we would say it has infinitely many solutions. The opposite of identity is a contradiction. So let me go ahead and clear the writing so I can show you what happens with a contradiction. Remember, for an identity, you get a true statement. So for a contradiction, think about what might happen there. For a contradiction, you're going to have no solutions. You could also use like this symbol, that's the empty set, but no solutions. Let's see what happens. I have 5x minus 15 equals 5x minus 4. 5 times x minus 4. 5x 2x minus 15 equals 5x minus 20. If I go ahead and add, subtract 5x from both sides, I get negative 15 equals negative 20. Is this a true statement? No, this is a false statement. Negative 15 does not equal negative 20. If you get a false statement, no x value will lead to a true statement. You'd get a false statement, and so there's no solutions. There's no value of x to make this true. So let's work through a couple more difficult examples. So I've got x plus 7 divided by 6 plus 2x minus 8 over 2 equals negative 4. Now, we typically don't like working with fractions. I know I don't like working with fractions. So one thing we could do is multiply by a number that would cancel out both of our denominators. Remember, what I do to one side, I have to do to the other. So what's the least common multiple of 2 and 6? Well, that's just going to be 6, right? Because 6 factors into a 2 and a 3. So I multiply both sides by 6, and I'm going to do this work up here. So I'd have 6 times x plus 7 over 6 plus 6 times 2x minus 8 over 2. Remember, 6 is a fraction with a denominator of 1. And 6 times negative 4 is negative 24. As we can see, 6 divided by 6 is 1. So I have x plus 7 plus 6 divided by 2, which is 3, times 2x minus 8 equals negative 24. So I have x plus 7 plus 6x minus 3 times 8 is 24. So I get negative 24. I combine my like terms, 6 and x gives me 7x. 7 and negative 24 gives me a negative 17 equals negative 24. I go ahead and add 17 to both sides. I get 7x equals negative 7. Yeah, I agree with that. Divide both sides by 7, because what I do to one side, I have to do the other. I get x equals negative 1. And I could check my solution if I wanted by plugging it into my original equation. Let's take a look at this more complicated example. It's not really harder, it's just got a lot going on, right? I've got two grouping symbols, I've got parentheses, and then I've got brackets. So I'm going to simplify the left, then we'll simplify the right, and then we will solve our equation. So I have 4 times 6 minus, 1 plus 2x. I can distribute that negative, so I've got minus 1 minus 2x plus 10x. I think I did this wrong in class, so you probably should have corrected me. So now I have 4 times 6 minus 1, that's 5 minus 2x plus 10x. Now I'm going to multiply. 4 times 5 is 20. 4 times negative 2x is negative 8x plus 10x. I simplify this to 20 plus 2x. So my left side's fully simplified. Now I'm going to simplify the right. 2 times 10 is 20. 2 times negative 3 is negative 6x plus 8x. So I get 20 plus 2x. Oh gosh, 20 plus 2x. So as we can see, these are equivalent. So I'd get 20 equals 20. This is a true statement. This is an example, of an identity. Very exciting. This is an example of an identity, and it has infinitely many solutions.